Hi, welcome to the ODI's Friday lunchtime lecture. Today's talk will be by Rory Scott from Open Data Services Cooperative, and today Rory is going to be talking about the changing role of descriptive code lists. For all our viewers who are watching remotely, if you've got any questions, please use the hashtag ODI Fridays. And for those in the audience today, please keep your questions until Rory's finished speaking. And we'll hand around the microphone. Please wait until you have the microphone before you ask the question so that our remote viewers can actually hear what you're saying. So I'm going to hand you over to Rory now. Thank you, Rory.
Hi everyone, thank you for coming. Code lists, machine learning, weird stuff. I'm going to dive into it. Basically, I'm going to try and cover quite a lot, and I think if anything's completely unclear, do just raise a hand and say, hey, can you just clarify that? Obviously, we'll do longer questions towards the end. So, as mentioned, I'm Rory Scott. I work for Open Data Services Cooperative. We aim to make open data useful, usable, and in use. I've tried to get everyone to patent this, but apparently it clashes with our mission. Can't patent things if you work in open data. We're a workers cooperative. That's really great. We own our business together. We make collective decisions. And plug alert, we are hiring. So please check that out. Anyone out on the internet who's interested in getting more involved in open data, please follow this URL or Google Open Data Services jobs and have a look. Cool. So I'm going to start with a few definitions, and I am sorry it's not a fun way to start a lecture, but I figure I might as well get it out of the way. So yeah, I'm guessing this room probably knows a bit about open data and open data standards, but oh, interesting. Sorry, I've just noticed that the bottom of my screen is cut off on this presentation, so I might try and have a think about how to solve that. Sorry everyone online who's watching. Maybe I can just zoom out and that'll work. Okay, well, I'm just going to crack on for now because I can't really think of a way of solving that, but hopefully I can remember what I've written. So I work primarily on open data standards, and they're both open standards and they're for open data. So an open standard is just a standard for expressing data that is governed and created democratically. So yeah, think ISO but without the paywall. Open data, hopefully everyone's kind of aware on that, but it's data published openly and transparently for public good. Right, so within these open data standards, there are these kind of, I like to think of them in two ways. There's syntax and semantics. So syntax is kind of the way that you structure your data. So you might have a schema, you might say that we need to have a project description followed by a transaction detail followed by X followed by Y. And that's all quite structural. Then there's semantics, and this is kind of more what the data is trying to tell people about the world. It's the meaning of the data. So, for instance, if you have a decimal value in there, and that pertains to a transaction, what does that mean? Has that meant that money has changed hands? Has that meant that someone's promised some money? Those are the questions of semantics, and it's those semantics that I'm more interested in today. So one way that people have typically tried to solve the problem of comparing data is using code lists, and these are they're semantic tokens essentially. So it's a way of saying, I'm going to put this placeholder in, and when I use it, it means this thing. So that can be an external source of kind of source of truth about the meaning of the data. So that could be anything from a transaction type, is it a disbursement, or is it an expenditure if you're talking in international aid terms, or it could be much more descriptive. What's the purpose of this activity? What's the purpose of this thing that's being expressed in data? So I'll go into a bit more detail on that later. Finally, there is a bit of machine learning that's used later on in this talk, and it's prudent just to say that we're talking here about unsupervised machine learning. So that means we don't have training data, we don't have hordes of well-classified, well-cleaned data, and we're trying to use those methods to find meaning within data sets that are kind of messy and as yet not very robustly analyzed or cleaned necessarily. So moving on. So this is the domain that I'm working in at the moment. So I do a lot of work on the International Aid Transparency Initiative. I also work a bit around 360 giving and open contracting. All of these are open data standards to help people be transparent about what they're spending, whether it's to do with international aid, whether it's to do with philanthropic grant making, or whether it's to do with public procurement and government contracting. So all of these standards involve networks of publishers publishing their data, being transparent about it, and then trying to inform decision making with it, trying to make sure that people know what other people are doing. Yeah, so let me just check where I'm at. Cool. So this happened last night. My colleague Stephen Flower, who often tweets about IATI, asked how many code lists are involved in IATI. We started with 5. I counted and got to 17. It turns out there are actually 62. Now, what I'm not saying in this talk is because some machine learning exists now, we can do away with all code lists, because loads of these are vitally important and they are very, very functional in their nature. So what I'm really talking about here is the descriptive code lists, the ones that are trying to imbue the data with a kind of vague sense of meaning that's not going to be piped directly necessarily into a functional system, a bit of software. So I think an easy way of walking through this difference is just to look at the 2 different colors of color coding I've done here. So if you look at all of these fields that I've put in blue, these are very functional fields. They're not vague, and they're often completely exclusive. You know, if there's one of them is there, it means there can be no other value there. So if you look in that top line, we've got the default currency equals USD. Sorry, I should say this is an IATI activity. It's XML. It's ugly to look at, but it's a useful way of looking at how these concepts apply to kind of real and raw data. So those kinds of fields there, I'm not really concerned with those here. I'm sure there are applications of machine learning and clever data analysis to them, but that's not really what I'm talking about. I'm talking about the descriptive and the ambiguous and the non-exclusive classification that's going on here around agricultural concepts. So we've got water resources, irrigation, we've got agriculture, we've got water administration. All of this is mentioned within the description text of an activity. And what this might all correlate to in terms of the actual code list used is just something like this, a sector code at the bottom here. So that's trying to encapsulate a lot of meaning into this sort of code. But also, if you look at that code, it doesn't immediately tell you very much. You have to go to an external resource, and you have to say, I think this code applies. Now, this is problematic for a couple of reasons. So one, the people who are actually trying to publish the data, it's not always immediately clear to them which code applies. So for example, you might have people who are at different stages of the data production process. So at one stage you might have someone in country doing something to do with international development, and they know exactly what is happening in their project. But the people who are responsible for making their project transparent and publishing it and making it open data might not have that intimate knowledge. And they might just be looking at a list of descriptions of codes and saying, I think it's this one, maybe it's that one. And certainly without naming any names, I've assisted publishers for many years, specifically in IATI, and I know that this process does go on. You have people who are trying to classify, and it can be quite difficult, to the extent that there are now actually tools that bootstrap from existing data. So I'm going to show you a little clip. This is a really clever tool written by Foundation Center. I wasn't entirely sure if I still had access to their API, so I thought I would just use a video that I recorded a while ago. So I don't know if people can see what's going on here. Maybe if you've got a full screen you can, but this is copying a bit of text in and then just saying go. And this uses a pre-trained, I believe it's a support vector machine, don't quiz me on the maths. And it essentially takes a huge load of data that already exists and tries to map the meaning of it to that trained data and gives you a load of suggested codes. So I mean, the mere presence of this kind of tool is indicating that people want to be able to classify their data better, but there exists this disconnect between what they know about their own data on the one hand, and what they could potentially know about all of the code lists that are available on the other hand. So that's a little bit about our domain. Move on. Okay. should pause before I do that. So, so what I'm going to do is I'm going to show you some analysis that I ran on various domains of big corpuses of text data that pertain to. So first of all, IATI. At one point, I went and I got all of the descriptions that have been published to the standard, and I did the analysis there. I also did it with 360 giving descriptions, so descriptions of grants that have been made domestically in the UK to do with philanthropic grant making. And I'm going to use some really clever code that I did not write, and full disclosure, don't fully understand in places. And the way I like to think of it is that it's a bit like a cover song. So I'm covering this guy's talk that I watched and was really inspired by. And just to kind of set expectations, it's not a particularly good cover. So it's not Erykah Badu's cover of Drake's Hotline Bling, which takes an objectively pretty terrible song and makes it great, and actually manages to mitigate some of the really problematic lyrics it has by completely striking them out. So that, 10 out of 10, really good cover. This isn't that. However, it's not Limp Bizkit's cover of Behind Blue Eyes, which takes an already pretty questionable song and makes it even more morose by having it delivered by Fred Durst. So somewhere between those two, I think a good way of thinking about it is it's like a folk cover of a Kiss song. So arguably, somewhat misses the point, and probably wouldn't be directly approved of by the original artists, and doesn't have the same level of expertise, where in the case of Kiss it's knowing how to celebrate that you have crazy nights. In this case it's learning how to reduce lots of text documents into a multi-dimensional vector space. So I don't really know how I did that. I used open source libraries and then I'm interpreting the results in the same way that these people may not know how to apply that face makeup, or they certainly didn't come up with it. So hopefully that's crystal clear. So this is the guy I'm ripping off. He's called Patrick Harrison. As far as I'm concerned, he's a genius. I don't know, but I watched this talk and later on had insomnia and decided to try and apply it myself. He's on GitHub if you search for this, and I'm presuming these slides could be distributed somehow afterwards, so there are links. So yeah, I am basically just doing a cover of this from here on out, but as far as I'm aware, this hasn't been applied, at least publicly, to anything other than Yelp reviews, which I also do in this, to give some context. So I've been talking for a while. I'm going to make sure I haven't missed anything vital before I move on. Yeah, just to kind of reassess the stakes. So I think what I'm trying to get across is that the techniques that come from here can tell us a lot about data without any code lists, and in a way could be taken in tandem with code lists as a really smart way of bootstrapping the whole process of making data findable and understanding what it means. So I'm now going to introduce a little bit of the processes that I use to do this. Again, the big proviso in place here is that I don't fully understand the maths behind this. I'm using open source libraries and kind of fumbling my way through a little bit. So please don't hold me to account if I've made any small errors, or rather do, but don't judge me too hard. Oh, right, okay. Does that mess up the streams at all? We're back? Brilliant. So the first step was using this package called Spacey. It's a Python package. It's incredibly clever. It does all of these different things. So tokenization, splitting things up, paragraphs into sentences, sentences into specific words, normalization, sentence detection, word vectors. All of these things are kind of in that same ilk of we're taking natural language and we're trying to turn it into something that can be reduced to more manageable structures. So for instance, named entity recognition is really cool. That's kind of taking things like geographical terms and understanding that they're geographical. So for instance, you could query the text data you've got for places and then use that in some kind of analysis. I don't do too much of that. What I do in this process is just kind of normalize it and get it to the most manageable and comparable state I can. So I'll walk you through the process with one of the Yelp reviews. So Jody G writes, so back in the late 90s, there used to be this super kick-ass cinnamon ice cream like an apple pie ice cream without the apples or the pie crust. All caps, so delicious. However, now there is some shit-tastic replacement that tastes like vanilla ice cream with last year's Red Hot. I don't know what that means, it might be really rude. In the middle, totally gross. Right, for our purposes, that's all I'm going to bother reading out. So we take that, let's take that, just that bit from however. So the first level of cleaning that I did was to do what is called lemma tithing. So here we take words like, I don't know if there's actually a very good example in here. Oh, that's embarrassing. So we essentially, as we'll see later on, it takes words that are some permutation of a root lemma. So something like developing, and it reduces it down to the lemma, which is the basic semantic token. So develop will be what it reduces it to. So and it also takes out this first stage takes out punctuation as well. So you can see for a start, it's kind of, oh no, sorry, I'm wrong. So you can see the word is has become the word be. So instead of it being this, so the word be is the root lemma of that particular word. So the existence word that's used there. So the next stage is to apply bigrams. And again, using very clever maths that I'm not going to try to explain because I don't fully understand it, is taking, so what you can see here is this phrase vanilla ice cream. Now clearly vanilla and ice have an underscore between them, and the way this has been achieved is by looking at the whole corpus of text data and looking for the common occurrence of certain tokens together and saying, okay, well they've occurred this many times in this order, and that is statistically above average for certain words, and you set a certain threshold and say anything that's above this threshold we're going to append together with a little underscore and say that is now a unique semantic token. So that instead of it being something about vanilla, the plant, and ice, the state of water, now we've got vanilla ice, which is a kind of, it's a funny start point because that actually refers to the wrapper. But as we can see, what we then do is apply this exact thing again, and we get a trigram, and that makes a lot more sense. So now we've got vanilla ice cream, and all that's done is run the same analysis and see, well, vanilla ice occurs only a certain number of times, but every time it does, it has cream after, presuming that no one was listening to vanilla ice when they were eating at a restaurant, which might have happened. So that's the first stage. And then we use this thing called latent Dirichlet allocation, which if I didn't understand the bit before, boy do I not understand this. I understand in broad strokes, and I'll try to explain those. So these documents on the top, think of them as individual restaurant reviews or descriptions for projects in IATI, or descriptions of grants in 360 Giving. What latent Dirichlet allocation does is it builds on another technique called latent semantic analysis. And what latent semantic analysis would do is say, for every individual word, bearing in mind now that the words have all become tokens, so they're lemmas and they've got those bigrams and trigrams, for every individual one of those, we're going to create a dimension. And a document is literally just a point in a really, really high dimensional space. So you could say, if a document is about, I don't know, guns, for example, it might score highly on the desert dimension and the eagle dimension. But if we'd run this bigram operation, there would be a token for desert eagle, and it might be higher on the desert eagle dimension than any other document. I'm sorry, it's incredibly abstract. Hopefully it'll look a bit more normal in a second. So latent Dirichlet allocation takes that incredibly highly dimensional space, and it finds kind of folds within it, statistically identified places within it, and calls them topics, and then represents the documents as combinations of those topics. So again, I can try and flesh out the details of it later in the Q&A, but hopefully this gives you a vague sense, and then as we get onto the actual application, it will become a bit more clear. So an important thing to note here is that for this technique, you set the number of topics yourself. You say, go and find me a bunch of topics and show me what you think they are. And then, as we'll see in a bit, you can have a look at those topics and look at the words associated with them. And then you, as the user or the practitioner, has to say, I think this topic is about this thing. So I'm going to give this a go. Hopefully it's going to work. Brilliant. Okay. So this is a thing called a Jupyter Notebook. I really like working in them. It allows you to program in something like Python or R, but also put text around it and create a bit of a narrative around it. So I've done all of my analysis in this. I'm going to try and just make this, I think this is actually already full screen. So people who are in the room, can you read this text at all? Or do I need to try and make that bigger? Okay. So this is a more fleshed out version of what I showed you earlier. This is a before and after for the data cleaning process. So here we've got a review talking about the food being okay at like most Moxie. And underneath we've got this almost incomprehensible spiel of words. So here, every time there's a pron, that means it was a pronoun and it's been replaced by this placeholder token, because having lots of I and she and they within your data wouldn't really make too much sense. And it's gotten rid of all of the kind of, all of the punctuation, all of the stop words, so and the and things like that have all gone. But what this gives us is a set of words which can be used to compare this description with any other description on a more or less like-for-like basis. So, you know, if one description was talking about the past tense and one was talking about the present tense, it wouldn't matter once we've done this cleaning process, because we're saying we're only looking at the lemmas and we're taking out all of the stop words. So if we're going to compare them on a what words they both contain basis, now they're a lot more comparable. So then, having run the latent Dirichlet allocation and then presenting it in this framework called PyLDAViz, which is amazing, we end up having this quite complicated looking infographic. So I want to break down a few things quickly. So what we're looking at here on the graph is, so there's this thing called multi-dimension. Sorry? Oh, just keep happening. It's still red. So bear with me. Okay. Apologies, tech problem. So in the meantime, are there any sort of small questions, clarifications? It's fine if there aren't. Sorry.
Your approach do you, so when you do diagram detection, do you remove the original, I want to say monograms, but that doesn't sound right.
Yeah, I go with unigrams, but
Unigrams is better.
no one told me to, I don't think so. Yeah. So yeah, that's a good question. So so for people at home, the question is, when you're doing the bigram and trigram detection, do you remove the original single tokens? And the answer is yes. So if we take a description like, or a phrase like vanilla ice cream, by the time that we've run the trigrams, I'm taking all of those sentences from one file, I'm comparing them with a model that I've trained to do that exact process. It then returns me the tokens that have been appended with the underscore, and I then write them to a new file and completely replicate the old file, but just with those underscores in place, which takes a long time, as I learned recently. Does that answer your question? Do you have any other follow-ups?
That does answer my question, I think. Yeah, I guess as a follow-up, so you're retaining some of the semantics. You're retaining some of the semantics, right? You're not. You're making a vector representation of the sentence rather than just counting the words.
Okay.
Like a bag of words approach.
No, the bag of words is comes as part of the latent Dirichlet allocation. So the n-grams, the bigrams and the trigrams, that's purely just statistical. Look at the co-occurrence of words by scanning over all of the documents. With the latent Dirichlet allocation, you have to vectorize in the way that you're describing. Apologies, everyone, this is a bit more technical, but so you vectorize the words, and then you feed them into a bag of words model, and then you build your vector space from that, and it's a sparse array. And then, yeah, if you want to talk a bit more detail about it later on, that would be cool. In the Q&A, we can go into it again as well. Okay, we can talk about it more now. Yeah. So, okay, cool. Are we looking? Hey. Here we are. Fantastic. Okay. So with that all being done, this first graph I want to show you, I'm actually going to try and zoom in here. Is that still legible? Yeah. So this first graph is looking at 840,000 Yelp restaurant reviews. So all of them have been treated in the way that I described, and then all of them have been fed into this model. And I think what it tells us is really, really interesting. So first of all, I'll just describe what we're looking at here. So in this area here, this big visualization, this is that really highly dimensional representation of all of the documents in the corpus, reduced down to 2 dimensions. And then basically there is an algorithm which says, globally speaking, how far are these 2 points from each other in all of these dimensions, and then tries to represent that in 2 dimensions. So again, maths ignorance warning, I don't understand fully how that process works. But what I do know is that I could change the way this graph looks quite a lot by using a different algorithm for it. But ultimately I've used the same algorithm for all of these, so I think it works on a kind of like-for-like comparison basis. So let's actually have a look at what's on this so far. So I think the first thing to look at is probably what's far away from everything else. So over here, immediately we can see this is just in German. And that kind of makes sense because it's trying to compare the common occurrence and the associated meanings of these words with the rest of the topics. And in fact, they're just in a different language. So it's never going to get a full read. So it's grouped them all together in this topic and said, I think these are all of a kind, right? And that's true of what appears to be kind of complete nonsense reviews. I don't know how these were made, but clearly there are a couple of words that have been repeated and used in the context of each other. And this is an interesting upshot of this kind of algorithm, is that it shows you weird stuff. And that weird stuff doesn't mean it's wrong, it just guides you in where you might want to take it in the future. So for example, all of these topics that are over here don't really increase our understanding of the meanings of the other bits of data, but it does tell us something about the source of data generally. So there is some noise in this data. Either Yelp haven't classified which language their reviews are in well enough, or some users haven't realized that they're on the English version of the site. That's all quite interesting diagnostic stuff. It's not specifically what I'm here to talk about, but it is really interesting. What I am here to talk about is this whole column over here. So let's just take a topic at random to begin with. Right. Can people get an idea for what that might be about? We could try another one. I mean, the word tie is in there, so I think that's a bit of a giveaway. Let's just try another one. How about, yeah, this looks potentially like it's got a common theme. I want to try and find a really nice, really obvious one. I know Mexican is around here. Okay, well, yeah, here's the breakfast topic. That's good enough. So here we've got at the very top, breakfast, coffee, egg, brunch, bacon, pancake. Now, that to me is, I don't need to spend any time thinking about what that means. That to me is like, okay, bang, this is to do with breakfast. I mean, it's the first word. But what I like about it is how clear it is that it's found this commonality and these words have been used in context with each other this much. So at this point, before I look at any of the other topics, I want to just show you another thing, which is this slider up here. Again, just in case it's unclear, I did not write this. This is written by geniuses, and it's a great Python package for displaying latent Dirichlet allocation in exactly this way. So this slider here, it allows us to change whether we're prioritizing the out-and-out relevance of a given word to a topic that we found, or the salience of that word. Now, the relevance is just how many times has it been featured in this topic. The salience is how specific to this topic is it. So if it's featured, so if we look at the word breakfast here, for example, and I click on it, I can now see this word pretty much only features in this topic. You know, if we take something else that's a bit more broad, like order, the word order shouldn't have any real bias because everyone who's going to go to a restaurant is probably going to have to order something. So I have a look at that, and yeah, there's almost no change, right? So if I look at the word order there, in 12 up here, the word order features there as well, quite heavily. But if we go back to breakfast, yeah, that's how we see so far. So if I now shift this towards the more salient terms, we start to see more specific terms to breakfast. So we're gonna cut out all of those ones that are potentially to do with anything, but just happen to be featuring in breakfast a lot. And we can go all the way to super specific, and we'll see something like egg Benedict, you know, or skillet. Skillet, that kind of seems, anyway. Right, so are there any questions about that? Because I'm going quite quickly, and I'm aware that it's, you know, big graphs and stuff. No? Okay. Cool. So I'm going to put the slider back up a little bit, and then talk about the actual layout of these graphs. So there's this big cluster here, and I think this, globally speaking, is a kind of these topics make coherent sense cluster in my mind. When I look at them, they all have something that I can identify about them, and they do kind of make sense. But what's interesting is that there are two kind of superclusters within it. So at the bottom here, we've got different cuisines and different types of food, by and large. So here we've got healthy options. This is basically, we've got vegan, vegetarian, gluten-free. Apparently these people like gelato and juice. They talk about it being delicious. You know, it's to me, again, there's kind of a clear picture being painted here. And if I go right down, again, we see, you know, there's a lot of emphasis on health, and there's a lot of foods that we strongly associate with healthy types, and some that we don't, but, you know, there could be decent narratives for why that's true as well. And equally, like if we just have another little walk around, we'll probably see, yeah, this is kind of, I think, vaguely to do with seafood. You know, we've got fish, we've got shrimp, Bloody Mary. These things kind of go together. Here we go, pizza, really obvious one. We've got burgers. What I really like about this one is the fact that like burger, fry, and order account for such a huge proportion of it. It's like just, you know, all these other words are associated with it. Like people have milkshakes with their burgers, and they have sweet potato fries maybe, but really they're talking about the burger. So yeah, I enjoy that. So this whole cluster here is kind of food options. And then as we go up here, we've got stuff that's much more to do with the environment and the setting and the experience. So this is to do with the crowd, the music, you know, what's going on around you. This is to do with, I think this is to do with the service, how long it took. So again, it's kind of interesting if we look at the more salient ones. Yeah, we've got like 10-minute wait, 15-minute wait, 20-minute wait. All of these are like really important here. So again, like this is, you know, if you were trying to come up with a way of classifying all of this data, you might have thought, oh, let's do it, you know, just by the kind of food there is. But actually, if you look at what's already in the data, look at what people are already saying, there's a clear topic for how long people are going to have to wait. And that, I mean, immediately that's interesting to me because I mean, you could get an industry expert in to start coming up with ways of classifying your restaurant reviews. But equally, you could just run this and be like, okay, people are talking about this. People are talking about how long it takes. So let's make sure that we have a way of anticipating that. And let's try and see, you know, if we can accommodate that. So yeah, I'm trying to think if there's anything else I need to cover in this one before I move on. I mean, it's just really cool. I could play around with this all day. Oh, this is the money topic, how expensive it is. And here's an interesting one, because I think there's a false positive in the algorithm, which is it's associated the word Vegas with this. Not because people, when they're talking about how expensive their reviews are comparing it to an experience in Las Vegas, but I think it's whenever people go to Vegas, they mention it, and they probably mention the price, and they probably talk about, you know, money, or I don't know. It raises interesting questions, and this is why I enjoy just playing around in this stuff. The last one I want to try and find quickly is the steak one. So if people see one that looks like it's talking about steak, shout, because there's a really funny thing in there. This is not captivating viewing, I know. Okay, well, I'll just tell you what it said. Yeah, in the steak one, there's all this stuff about, you know, the tenderness of the cut and rare, medium rare, well done, blah, blah, blah. And then about halfway through, just the word wife is there. And the theory proposed by Patrick Harrison when he was doing this talk, I'm fully plagiarizing at this point, by the way, was, I think, or maybe he didn't say this, maybe I thought this, that might be libelous, my theory is that the kind of people that will often go and write reviews of steak restaurants are the kind of people that will talk about taking the wife with them, because for me there's no other reason why that would be so strongly associated. Like, the word wife is being used in steak-based reviews a lot, and it's just an interesting question. Like, I don't know what value there is to that question, but it is still an interesting question. Why do people talk about their wife so much when they're talking about steak? Okay, so enough about that. So yeah, to sum up on this one, restaurant reviews, there's lots of them. There are actually way more than I used. I used 850,000 because that's roughly the number of reviews I had for the number of descriptions I had in IATI. So I thought try and make it kind of like for like, because obviously if you've got like 5 times the amount of training data, your results are going to be more reliable and more systematic, as just in virtue of that. So, but I think what's worth taking away from the restaurant reviews is that no one here is an industry expert. No one here has any idea of anything other than, I went to a restaurant, I enjoyed certain aspects of it, I'm going to rant about it on the internet. And it gives us these really clear, useful results. And more profoundly, these things are data structures that can be used in the future. You can derive the meaning of a new description or a new review by feeding it into this data structure and saying, I'm going to strip out all of the stop words, I'm going to turn it into a lemma, I'm going to put bigrams and trigrams in, and then I'm going to say, what is this nearest to out of these topics? And it can spit back at you and say, I think this is a 30% representation of the steak topic and a 50% representation of the I got bad service topic. And you can be like, wow, okay, cool. I know where to store this review now. I know if someone's searching for bad steak experiences, I know where to show them to. I can show them the reviews. So basically that's really cool. That blew my mind when I saw it. Now I'm going to show you a little mid-ground. So I have to again be a bit careful in terms of what I'm claiming here. This is very old data from 360 Giving that I got a while ago, and it's not very much. So I've tried to get it to identify fewer topics to make it work a little less hard. But that's also slightly opinionated because 360 Giving is philanthropic grant making, and it's domestic. So it's not this overarching global initiative like IATI is that covers humanitarian spending and all this other stuff. So I thought intuitively, really, without actually knowing as much as I should about the standard and its data, I thought, okay, I'm going to go for slightly fewer topics. But I think the results are really interesting. So first of all, let's have a little look. I actually wrote, unlike the rest of my talk, I did actually prepare this bit. So I've got a few topics to show you guys. Do I? Maybe I don't. Okay, apparently I don't. So. Oh right, okay. Is that any better?
Probably, yeah.
Okay, cool. Okay, so I'm gonna have to do a bit of scanning around. So apologies for the experience there. So first of all, let's look at number 4. I seem to remember. So here we've got a lot of stuff to do with schools and clubs and halls and community stuff, and young people play a role as well, which is quite interesting. If I bump the salience a bit, we can start to see a little bit more coming out, a little bit more, and it kind of it speaks to me about facilities and places where people can do things. So we've got a lot of, specifically it talks about facilities a lot, installing things, refurbishing things. So it's kind of logistics. And again, so it's not as clear cut as they're clearly talking about steak, but it's still, I can start to see quite a useful cluster here. This is the kind of thing that you might want to have in addition to a different classification and say, oh, it's got a bit of this in it. That implies that there might be, I don't know, even just, you could just say, okay, this is probably going to be like risk assessments involved with this because they're going to be building stuff. That's kind of useful. Here we've got one that's specifically to do, I think, with old people and the aged. So if we go back up to the more just out and out relevant, we've got community use, activity, funding. These are all quite generic terms. So again, if we go back down to the salience, we get like old people celebrate, reduce isolation, heritage, community, sensory garden, really interesting, become more active. So I think kind of intuitively, if I was to say all of those words at you in the order I just did, you'd probably start to think, okay, this is something to do with helping old people and helping them be more connected and more healthy, which again is a really cool find. There's another one which I really want to show. Yeah, so this is to do with education for sure. Lots of stuff to do with schools, computers, children. Again, like it's fairly intuitive when you look at it. You don't have to contort your mind too hard to see a common theme here. And again, if we put some of those more kind of filler words in, yeah. And again, just to show that it is working, here we've got primary school as a bigram. That makes perfect sense. And generally speaking, the bigrams and trigrams in 360 giving data are making a lot of sense as you look at them. Like voluntary organization again. And I'm just going to, because this is relevant for the IATI one, I'm going to show you, as you get more specific, there are more bigrams, interestingly. So wildlife habitat, business plan. I mean, we've started to lose a little bit of a sense of what the actual topic is with this one, but you can see building capacity, wildlife habitat, energy efficiency are all, interestingly, okay, so this is a nice segue into what I'm going to show you with the IATI one. Here we've got across Northern Ireland as a trigram. So to me, that indicates that someone who's publishing this data has talked about Northern Ireland a lot, but they've talked about it specifically in the context of saying this is a pan-Northern Ireland thing. So they will have said across Northern Ireland enough times that this algorithm has said that's a semantic token unto itself. That's quite interesting, and again, that becomes very, very relevant in the IATI one, which I'll move on to shortly. The last thing I want to show you is all of these are like sat right next to each other, and we've only got one that's sat really far away. And that turns out to be the specific topic found for taking Second World War II veterans on commemorative visits to the Somme, I think, or to Normandy, which is fascinating. And I mean, just for the sake of context, like that specific phrase, Second World War veteran, has been used 30,000 times in this data corpus. So I saw this and I was like, whoa, this is incredible. And then I actually spoke to, it's all right. I spoke to some of the great people that work at 360 Giving, and they were like, yeah, that makes sense. You know, there's someone who publishes a grant for every time they fund someone to do that. And clearly they've done it a lot of times, not 30,000 times, because they probably will have used this phrase a few times and there's probably a few bits of duplication or whatever, but to me that was like, I looked at it and I knew when I was running this, I knew basically nothing about the standard. You know, I knew in broad sweeps what it was about, I knew about its aims, but I hadn't gone and delved into the data. And to suddenly see this kind of clear as day representation of this very specific thing that's funded a lot of in the data standard, I was like, wow. And again, back to my point, I'm pretty sure there's no codelist anywhere that says, here's the code for funding World War II veterans to go, you know, it might fit into a broader code and it might fit into a broader classification, and that's useful, and I'm not saying people shouldn't use that, but this kind of approach of using what's already in the text data is clearly really powerful, and you wouldn't expect people to have already codified this. It's an emergent property of the data that's being published, and that is really cool. Any quick questions on the two that I've shown so far before I move on to IATI? Cool, okay. So this is the really fun one. So I'm going to start with the one that makes sense. So this is a lot more busy as a graph, and I'm going to try and resist my instinct to just use my hands. Are you, if I go and walk in front and do a bit of pointing around but not directly in front? Okay, I'm going to do that because I think it's easier than me trying to use the mouse for everything. So just initially, maybe I can use the shadow? No. Okay, so first things first, here is what I call the makes sense cluster. I'm going to come back to that. So in the same way that in the restaurant reviews we had the kind of specifically about the food and then more about the experience around the food in two different clusters, here we've got three big clusters. I feel a little bit like I'm doing the weather now. We'll have makes sense cluster over here. If I'm right, this is the it's in the wrong language cluster. And then sweeping down here, we have the more and more jargonistic language used to the point of becoming incomprehensible, or not incomprehensible, but not very useful, down to the they just used a stock description for every single activity. And so I'm going to take a little walk around that. So first of all, let's have a look at the wrong language. Yeah, no surprises there. Very similar to the restaurant reviews. Yeah, I'm gonna skip past that because we're kind of running low on time. But you can see what's happening there. Now let's go to the makes sense cluster. I love this place. So let's just do a little whistle stop tour. I'm going to go to point 6. So here we've got stuff to do with community building and sustainable development. It's kind of vague, but it makes sense it's a massive cluster because probably most development projects are going to be about this sort of stuff. We can get a bit more specific and see if there's anything else. But yeah, I read this as kind of like, it's talking about international development. Like almost everything published to the standard is aid. So it's probably going to feature this topic to a certain extent. FYI, my power's quite low, so I'm going to try and rush a bit more. Here we have the agriculture cluster, really clearly talking about farmers, agriculture, animals, productivity, farm, food, crop, loan, credit. Like this all kind of makes sense. And I worked a lot on agriculture recently, specifically in the context of open aid data. And so when I saw this was really interesting. Yeah.
Do you want to?
Yeah.
Yes.
I was wondering, are the inputs for this free text, or is it markup?
Completely.
Like you showed? It's all free text.
Completely free text. Yeah. So no formatting whatsoever.
Okay.
Yeah, and no syntax around it. So sorry, yeah. So in that example I used in my slides before, let's just quickly go back and have a look. Sorry, walking back through the past. So this is where it says description here. It's everything between these two elements, the description element here and the closing brace for the description. So it's literally just taking in that free text and using it. So none of the other data is relevant. I mean, it is relevant broadly, but it's not relevant to what I've done. Okay, so we can talk about the make sense cluster a bit more, but ultimately it does, broadly speaking, make sense. And that's the main takeaway we need. And again, I could sit and walk around these topics all day, but that's the most important thing. Now, as we go down this sweep, we start to see things like, let me just find a good one here. So you see what's happened with the tokenization here? So interestingly, not only have we got lots and lots of, let me just move this back up to one of the most popular ones. Okay, so they're still here in the sort of top level, and they're all really specific to this topic. Now, this is interesting because what's happened here is that the n-gram, the bigram and trigram detection has found these phrases used so commonly that it's completely broken it, and, well, not broken it, but it's just said, this must be a specific semantic token because it's used so commonly that, and you could conceive of a 4-word n-gram token that is a specific thing. The name of an organization, for example, if you said, something like the UN High Commission for Human Rights, is that the right acronym? That could be a big n-gram token and it would make perfect sense. But here we've got, routine immunization, polio eradication. So they've used that specific phrase a lot, and this has happened over and over again. And basically what we start to see is more and more topics are doing that and becoming, there's more kind of uniformity. So for instance here, thank you. Here we've got a whole topic which is, so roughly speaking, this is like a little under 10,000 is the count for all of these ones down here. You can tell from the fact that they have this uniform width, they've all been used the exact same number of times. And here's the scale of the times they've been used. So something like program has been used nearly 60,000 times throughout the whole corpus. But here, all of these tokens that have been found by the overzealous n-gram detection stuff, if we're thinking this is 20,000 about here, that makes this about 10,000. So this is kind of right about 5,000. So yeah, so someone has used the same description for 5,000 different activities, almost certainly. That's the only way that happens. Or they've accidentally pasted the same description text 5,000 times into one document, which seems probably more unlikely. And then we start to get to like the real offenders down here, where, we're talking like over 10,000 now, and for something like incur cost overseas, or by headquarter office, it's conceivable that they'd be used that many times, but it is jargonistic. It is clearly like, probably a lot of copy and pasting is going on, is what I'm saying. And then I want to try and find the big one, like the ultimate example, which is somewhere, I think, way down here. Yeah, here we go. So this one, you can actually see who's done it. And sorry, Carl, if you're watching, from CEDA, but yeah, CEDA have published somewhere in the region of 70,000 identical description texts. And you can see like it's found all of these things, and you can almost reconstruct the sentence from looking at it. Like, please check if their contact CEDA directly, activity or contact. Yeah, like you could put this together and build the description and say, I think this is, it's basically saying, we don't have a proper description. Please contact us if you want to know more. And here you can see all the little variations, like 2000 does not have, 2003 does not have. So, and this isn't hating on CEDA, because they've got, I know and I've seen, they've got loads and loads of really great data in there, and they have used good descriptions, and it's unfair for them to be singled out like this, because this is probably a relatively small fraction of what they've published, so it's not representative. But you don't see this in restaurant reviews. You don't see this kind of repetitive language that lends itself to overzealous tokenization, and this seems to be something that is more specific to international development, I think. And I didn't really see this with 360 giving either. So again, there are other variables at play that we need to be cognizant of. It was more data than 360 giving, so I'm not making this about IATI versus 360 or anything like that, but it does show us, this graph does show us something about the kind of language that's used. And so ultimately, I should go back to my slide for the kind of rounding off bit by now, because I've been talking for a long time. Where are we? Yeah, okay. Sorry, this is a shoddy affair. I didn't prepare very well. Okay, here we go. So yeah, noise is bad, and heavily jargonistic language shows itself in this kind of context. So I really want to stress, this is me having done some coding in my bedroom and letting my computer whir away for a few hours. I'm not the kind of data scientist that could confidently come out and say, I have established new facts. I'm saying more of this stuff needs to happen in the context of open data, because there are immediately really interesting questions raised to people who do very little other than run some code that someone else has written and have a look at the results. So the normative prescriptions that I want to bring out from looking at this is, yeah, this is really has a lot of potential. And it tells us about what's actually in the data. So in the case of something like IATI, lots of people have tried to use the OECD DAC code list, and you can never really be sure. Sorry, these are purpose codes that say this is to do with water and sanitation, or this is to do with food security. You can never be fully sure if people have used them exactly right, and people try to use them for statistics purposes, and that's all great, but ultimately just looking at all of the texts that have been published can tell you a lot about what's in there, and potentially can create an infrastructure for classifying things in the future that's really promising as well. And so yeah, that kind of dependency on code lists is starting to wax and wane a little bit, I think. And equally, what's cool about this is that it didn't need any training data. It's completely unsupervised. You just say, get me all of the text and run it and see what it tells me. So the barriers to entry are quite low. You don't need to go and acquire a huge amount of data to actually run this kind of code. So yeah, I think the final, my smiley face emoji has turned to an empty box. That's just so deflating. Yeah, this basically, for anyone who's going to publish some open data and they're worried about whether they've got the right code or which taxonomy to use, or anything like that. Really, whatever you do, if you're going to publish some data online and there's space for you to describe what it is, describe it in as much detail as you can and as usefully as you can, and describe it in a way that makes sense to humans. So don't just mask it behind really jargonistic business speak. Like, actually say, I'm going to do this thing. It's going to help these people. And even if that duplicates some of the stuff that you've managed to pack into standardized conduits for descriptive meaning, like purpose codes, still put it in, because then I can run this again and I'll be able to learn more and it'll be really cool. So yeah, that's it.
Thanks, Rory, that was really great. So for the people online, sorry about some of the technical issues that we've had. Hopefully we'll be able to get those online so that you can see them afterwards. We've got time for a few really quick questions, I think. Did we have any questions in the audience? Yeah.
What's your views on collective AI technologies and the advancements of collective AI I've got a question on like the advancements in data collection in AI and like how they sort the data and like how fast the computer will process the data and come up with like an evaluation of the data result and like give you an insight of like what the data is and how the data is run and is collected. But like what my main point is like how the future of like Britain is gonna like basically like record their like history and like how you gonna store the data. Is it gonna be in a cloud? Is it gonna be virtual? Is it gonna be is it gonna be in like a new virtual reality network of collecting data? But like on like the basis of like the advancements of technology, because basically what I'm doing, I'm building my own cryptocurrency, and what I want to do is like collect data on cryptocurrencies itself. So like what I'm trying to introduce is like introduce people using their daily lives on like their cryptocurrency points and collecting data on that and basically making it score into a point of like a life point skill. So you get a skill point life on all the data that they've collected from you from like a user page basis of like you filling out questionnaires, surveys, and like you getting paid for that as well, because when you're doing it, you're getting paid on a basis, yeah, that you're getting paid on a basis that
I think
sorry.
I've stopped being able to follow.
I know. Sorry.
But I think the only thing I'd say is I know very little about cryptocurrencies and I know very little about data storage. All I do know is that the advancements in AI are wildly beyond anything I can really understand. And the real gatekeeper to all of this stuff is not the cleverness of the tech or the algorithms. Like the stuff that I've just showed you, people just publish that online to get a good portfolio. They're just like, check out this code I wrote. It's all to do with the actual data that you hold. And that's really like, this is why it's exciting to have open data movements where there's this huge repository of data that you can go and look at, is that it gives you some kind of way of not competing, but you get to exercise that kind of machine learning and stuff.
This is what I want to even say as well, because I wanted to like try to build a system where it makes it easier for scientists to like compare and compete with like so when they're collecting data on sites like a species or an animal, they can compare it with other people's data collections, and they can have an automatic like prediction. So like when they've collected the data and they've come to evaluation that they've changed this data, like there's been a change in the data that's been collected, they can instantly change it within like a network of all the scientific
I've lost you again. Can we chat about this after? Because I think it might take a while to explain, but yeah. Thank you though. Okay, cool.
Just a couple of quick questions. Each document you placed into one of a number of different clusters.
No, so each document was used to train, was vectorized and used to train a model. That model then looked at the resulting space that was made, which is very highly dimensional. And then it makes a bunch of mathematical assumptions about the existence of Dirichlet, and that's a topological feature within the vector space, and that is what we say is a topic. So when I say find me 50 topics, it goes and looks for the 50 most distinctive of those, and there's lots of conditional decision making that happens behind the scenes there as well. So each document can be represented as a combination of the topics with a weighted is a weighted vector of the different topics, basically. Right. Does that make sense?
Yes. My question was when you said 50 different clusters, do you determine it's 50 or does the
I change a value in the code and then it looks for 50 or it looks for 40.
Okay. Do you have a rule of thumb for deciding how many? Or
so it's been very exploratory at this point. The original talk that ran it on the Yelp restaurant reviews used 50, and I had roughly the same amount of IIT descriptions as I did Yelp reviews. So I said, okay, well I'm just going to use it to find 50, and I played around with it. I did more and less, and the results were interesting, but that was the most clear representation I found. And then I played around a bit with the 360 giving one, but ultimately, if the topics that you found using a lower number, like 25 or 10 or something, make lots of sense, that's still quite interesting. So I thought I'd present that. But
Okay.
it's a good question. I'm
Good.
sorry, I definitely skipped on quite a few of the details.
Right. No, that's fine. Thank you.
Yeah.
Should we take one question? Have we got any Twitter questions or anything like that? No? Okay, I think we should wrap up then because we've slightly overrun.
Sure.
So thank you for coming to the lecture. There won't be a lecture next week, but there will be one the following week. That'll be our Christmas special featuring the ODI's very own Dave Tarrant. And that will be around Open Christmas, Internet of Things. So thank you everybody for attending.
Thank you.
Thanks.